Okay. All right, Adrian, thank you for meeting with me to look at this problem. Okay. So, all right, here's your problem. And then I'm gonna give you the scratch paper, okay? And something to write with. So, all right, can you first start by reading the problem out loud?
Sue and Julie were running equally fast around a track. She started first when she had ran 9 laps. Julie had ran 3 laps. When Julie had completed 15 laps, how many laps had Sue run?
Okay. All right, and just to make sure, this was Sue started first, not she. So Sue started first, okay? Just so that you know that you've got 2 different runners, okay? So, in your own words, can you tell me what this problem is asking for?
It's asking, like, if Julie completed 15 laps, how many laps did Sue finish?
Okay.
Yeah.
Good job. How would you go about solving this problem?
You'd probably, when she started, okay, Sue ran 9 laps, Julie had ran 3 laps more. So you'll probably, and then Julie had 15 laps, you'll probably have to find how many Sue ran, so you'll probably have to do your equal problem.
Okay.
Like that, and then you'll probably find, yeah, like that.
Okay, well can you start solving it for me, please?
Let's see if we can do this. Okay, she started when she had 9 laps, so Sue's probably going to be 9 laps, and she's 15 laps. So this one's Sue, this is a question mark, and this is, but then again, Jewel had ran 3 more laps. So is it going to add to this?
I want you to tell me what you think the problem is doing.
Laps, and this is probably 15. This would be 3 more laps, so it's saying if she ran 3 more than her, so she's probably gonna have less than her, right?
Who put a name with who's running more? Who are you saying is running more?
Julie. Because it said Julie had ran 3 laps, but when Julie had completed, she ran only 15 laps. So how many laps did Sue run? But Sue already had 9 laps already completed, but she's not done yet. But she's done right here, so we still gotta probably solve how many she laps. So we're probably gonna have to divide or add or do something like that.
Okay. Okay. What were you wanting to set up right here when you solved this problem? Do you remember what this is called?
Ratio? No, proportion.
A proportion. Okay. So you're wanting to set up a proportion, right?
Yes, ma'am.
So are you just a little confused on where to set the proportion at? Okay. Well, what if this is a good thing that you put Sue here. So you had Sue ran how many laps?
9.
Okay, and what do you want to compare those 9 laps to?
3 more.
Who ran those 3 laps?
Julie.
Okay, so where could you put that in your proportion?
Right here.
Okay. Okay, so you're saying Julie and Sue, okay? And remember, on proportions, however you set up the top is going to be, what do you have to do on the bottom?
You gotta divide by something.
Okay, you're close. So what I mean is, if you put Julie on the top here, who do you have to put here?
Sue, right?
However you set up one is how you have to set up the other one.
So we're gonna have to.
So if Julie's here, who needs to be here? If you're going Julie to Sue, this is gonna have to be who to who.
So they ain't gonna have nothing on the bottom, right?
Well, they could. If you're comparing Julie to Sue, this one's gonna have to be Julie to Sue as well. So what else do we know about Julie, about the problems?
That she already completed the laps.
How many laps?
15.
So do you have Julie over Julie?
Mm-hmm.
Yes. Okay. So this one, to make it equal, has to be Sue over
Sue.
Okay?
So we're gonna have to. So we might have to divide 9 into 3 or 3 into 9.
Okay? What do you think you would do?
Probably divide by.
What number are you going from?
3 divided by 9, because if you do 9 divided by 3, you can't get it in. Right?
You're saying you can't do 9 divided by 3? You can't?
No.
Say that out loud. 9 divided by 3.
9 divided by 3.
And you're telling me that you can't do that?
No, because if you can't get nothing into 3, right?
You're taking the amount of 9 and dividing 9 into 3 areas.
So it's going to be 3. So it's going to be 3 divided by 3 is 9.
Okay. Draw 9 circles over here. And I want you to put those into groups of 3. No. Take the amount and divide it into groups of 3. Take those 9, and I want to know how many groups of 3 can you make?
How many groups of 3? That's 1, 2.
Okay, I see. Okay.
3.
These are 9 candies, and I want you to divide them out to 3 different people. How many pieces of candy would each person get?
You have to. So 9 people are gonna get 1.
Okay. You're gonna give away 9 pieces of candy to 3 different people. Okay.
Okay.
So you could start by each person getting a piece of candy, right?
Mhm.
So mark it out. So that person gets 1, that person gets 1, that person gets 1. Now, okay, you still have how many pieces left?
5. 6.
Okay. So how much does each person have right now?
3. So if you get, that's another person, that's another person, so each person is gonna get 2
Right.
now. But then you still got 3 more,
Uh-huh.
so each person gonna get 3.
So what is 9 divided by 3?
3.
3. Okay. So, but right here, you're saying 3 divided by 3. What is 3 divided by 3?
1.
1. Is that what that is? No.
9 divided by 3 is 3 though.
Yes, so you could go 9 divided by 3 is 3. Okay? But then, if you're going from Sue to Julie, you're going to have to go from Sue to Julie here, right?
Mm-hmm.
So, do you know that number?
No.
So we're going to have to say, what number divided by 3 is
15.
15?
5.
5 times 3 is 15.
Oh, yeah.
Or 15 divided by 3 is 5. Can you look at this another way? Can you go from 3 to 9?
No. Okay. No, I think you go from 3 equals 9. Divided 3 divided by 3 is 9.
Can you multiply instead of divide?
Mm-hmm.
What would you get?
3. 3 times 3 is 9.
Okay, so you could do it that way.
So
3, so instead of divide by 3, you could multiply by 3, right? So you could say 3 times 3 is 9. Okay? And so then what if I always said whatever you do?
to the top you got this.
Uh-huh.
So times 3.
Mm-hmm.
So it's gonna be 45.
Okay, so do you think that's the answer to the problem?
Nah. Oh, yeah.
Yes? Okay, can you read the sentence with the question using that as your answer?
Okay, when Julie had ran 15 laps, how many laps has Sue ran?
What did you get?
45.
45, okay. Do you feel confident about your answer?
Yes.
Yes. What did you set up to solve this problem?
A proportion.
A proportion, okay. So, now, do you think that the time, did you consider the time difference of when they started?
No, ma'am.
No, you didn't? Do you think that's important? Do you think that would change your answer? You do think it would change your answer?
Not really.
Not really? So you still feel good about 45 as your answer?
Yes, ma'am.
Okay. What else do we know about Sue and Julie when they were running? What does this first sentence say?
They equaled fast around a track. So they have probably the same amount of laps, right?
You think they have the same amount of laps?
Yeah, because it said it equaled fast around the lap.
Well, what's the word before equally?
It said running. Before or after?
Right here. Just reread the first sentence.
Sue and Julie were running
Equally?
fast around a track.
So what was the same for both of them around that track?
One.
Oh, okay. If they were running equally fast, does that mean was their speed the same?
No. Oh, yes. No.
So,
No, because it says Sue started first, though.
okay, Sue started first, but did Julie join her at some point?
Mm-hmm.
Okay, and when Julie joined her, so imagine you and Juan are running around the track. You started first, and then Juan said, "Hey, Adrian, what's up?" And he joined you. What, y'all are running how fast though? Equally fast. So are y'all completing the lap together? Yes. But, okay, so you and Juan are running. Did you start before Juan showed up?
Yes.
So say you ran 2 laps before Juan showed up. So you were running. Do you see yourself running a lap? And then you were running a lap, and then Juan said, "Hey, Adrian, I want to join you." And then y'all start running together, right? So how many laps have you run by the time Juan joined you?
Already 2.
You had already run 2. So then by the time Juan ran 1 lap, how many had you run?
3.
3. Because you ran the 1 lap with Juan, right? And then, but you had already run how many laps before that? 2. So then, what if y'all both just got tired and you said, "I'm done," and you both stopped at the same time? Would y'all have run the same number of laps?
No, because I started before him.
Because you started before him. So now, do you think the fact that they didn't start at the same time is important?
Yes.
Yes. Do you think that's going to change your answer of 45?
Yes.
Yes. Okay. So do we want to go back and look at the problem again?
Yes, ma'am.
All right. So we set up a proportion here, right? Do you think, is there another way we could set up the problem?
Yes.
I mean, it doesn't have, you can, any way you would want to, what do you think would help you on solving this problem?
Probably the box that we learned.
The percent bar?
No, the box where you had to, like that.
Okay, show me the box.
It was like that, and they had to equal, and then we had to do that one, that one, that one.
So the 4 P's.
Yeah.
Okay, alrighty, so we can start with the 4 P's. What do we have any, we're going to preview the question, do we have any graphs, pictures, or any of that?
No.
No, so we could put no in that first box. Alright, what do we know about the problem?
That they both ran their laps.
Okay, are they running at the same speed?
No. Oh yes, but she started before.
Okay, so we could put same speed in that box, right?
Yes, ma'am.
And who started first?
Sue.
Sue started first, okay? So let's add that too. Sue started first. Okay, so now, okay, The question is, what are we trying to find out that the question is asking?
When Sue had completed 15 laps, how many laps did Sue? Oh, it said when Sue had completed 15, how many laps did she had to complete? So she completed 15. So how many laps had Sue? So it's not saying she is done yet. It's saying if she ran 50 laps, how many more laps did she run?
Did Sue run?
Yes.
Yes.
So she started first. So she's probably gonna run. If she ran 15, she's probably gonna have 17 if they started. If she ran 2 more than her.
Okay, where did you get the 2?
From that story.
From that story. Is that the same story as this story? No. So, but your thinking is right. So take the story I told you, and how can you apply it to this?
Oh, it's saying she had ran 9 laps, Julie had ran 3 laps. So when she ran 3 laps, Julie had 9.
Right.
So it's gonna be 15 plus 9, right? Because it's gonna be when Julie had 3 laps, she had 9 laps. So it's gonna be 3, 4, 5, 6, 7, 8, 9. So she's gonna have 6 more laps in her.
Okay.
So 15 plus 16 equals 15, 16, 17, 18, 19, 20, 21. So she's gonna have 21 laps, and she's gonna have 15.
Who's going to have 21 laps?
Sue.
And who's going to have 15 laps?
Her, Julie.
Julie. Okay, is that different from that answer?
Yes, ma'am.
But what answer do you think is most mathematically correct?
The second answer.
The second answer, which was what?
How could the second answer that we did with this?
With the box? The problem solving box? And what did you get? How many laps had Sue run?
21 and she ran 15.
And who ran 15?
Julie.
Julie. Okay. So, how did you go about finding that difference of 6? How did you know to do that?
Because I read the answer, and then when I read it first, I didn't really get it, but now I'm getting it. Like, now I understand it because it said when Julie had completed 15 laps, how many laps. I thought it meant, like, she already completed 15 and she was done. And it said how many more laps did she have to run. That's what I thought it said.
Oh, okay.
Yeah.
So, did going back to this first question saying they were running equally fast help?
Mm-hmm.
Because were they running together?
Yes.
Yes. Except, did they start together?
No, ma'am.
No. If they would have started together,
then they would have run the same amount of laps.
they would have run the same amount of laps. And this proportion right here, this would be if they would have started at the same time, and you're saying Sue ran 3 times faster than Julie. But was Sue running faster than Julie in this problem?
Yeah. No.
No, they were running at the same
amount of speed. She
right.
just started first.
She
started early and she had more laps than her.
Okay, how many more laps had she ran before Julie joined her?
9. She ran 9 laps.
Before Julie joined her?
No, she ran 6.
She ran 6 laps, and then when she started the 7th lap, who joined her? Julie, and then they ran together, right? And then Julie got tired at how many laps?
15.
And so by the time she got tired, Sue said, I'll stop with you, and she had run how many laps? 21. Okay. So, do you have any questions about this problem or how you went about solving it? No.
I just the reason why I didn't get it at the first because I just wasn't reading it right, and then how you explain how we're running now.
You got it with that?
Yeah.
Okay. So did the fact that they didn't start at the same time affect how you would solve this problem?
Yes, ma'am.
Yes, it would. Okay. All right. Well, thank you, Adrian. Good job.
Do I throw this away?